Welcome to my YouTube channel. Dhanesh here. So today we are going to discuss about one important aspect known as cost function. So we are going to discuss about cost functions given here. It is denoted by the letter J. So the cost function we usually use in machine learning, reinforcement learning, deep learning, neural networks, statistics, economics. See, all these fields we use this cost function. From a machine learning point of view, it measures the performance of a machine learning model for a given data. So what is cost function? It measures the performance of a machine learning model for a given data. And cost function quantifies the error between the predicted value and expected value and present it in the form of a single real number. In simple terms, we can tell cost function, it gives the error. Cost function, it denotes the error, and error is equal to the predicted value minus expected value. So this is error. Error is given by predicted value minus expected value. Cost function simply denotes error. And this cost function, it has two purposes. One is to minimize the error. Cost function is used for two purposes, and the second one is maximize the reward. See, to minimize the error means the difference between the predicted value and the expected value should be less. We know the machine learning models we used for prediction. So when a machine learning model is using for prediction, the difference between the predicted value and the expected value should be as low as possible. So the cost function, which is denoted by the letter J, it is used to minimize the error and maximize the reward. See, this thing we usually understand when we talk about reinforcement learning. See, you know, the machine learning is of three types. One is supervised machine learning, unsupervised machine learning. The third one is reinforcement machine learning. See, when we discuss those aspects, you will understand more about this, reward. So for the time being, we can understand the cost function is used to minimize the error and maximize the reward. See, let us consider a hypothesis like this. See, this is a hypothesis or a machine learning model. Hypothesis is y is equal to wx plus b. So this in simple terms. If I am this hypothesis, if we analyze in simple terms, you can understand it as it is the equation for a straight line here, and w is the slope. We usually denote it as, see, we can write it as y is equal to mx plus b. This is what I have written it as wx plus b. Both are same. See, for a straight line, m is the slope here and b is the y-intercept. But for a machine learning model, this y is the predicted value. See, this y denotes the predicted value and x denotes the training data, and w is the weight of the network, w is the weight, and b is the bias. See, the cost function, the important point is the cost function depends on the weight and bias. It's a function of weight. Cost function is a function of weight and bias. See, weight is the slope of the model. See, weight, we can tell it as in simple terms, in mathematical terms, it is simply the slope, and bias is the y-intercept. So the cost function, it depends on two important parameters. One is the weight and the next one is the bias. So that's why I have written cost function is denoted by the letter J, and it is a function of w and b. W is the weight of the network, and B is the bias. And again, when we discuss about cost function, then mainly there are two types of cost functions. One is the mean absolute error, it is denoted by MAE, and mean squared error, it is denoted by MSE. So there are two types of cost functions we usually use in machine learning and data science. One is the mean absolute error, and the second one is the mean squared error. See, to understand this, I can tell you the formula for mean absolute error. See, mean absolute error, here you can see it as it is equal to 1 by m. Sigma I is equal to 1 to m y dash minus y. See, what is m here? M is the number of samples in the data set. M is the number of samples. I is the index of the sample. So mean absolute error, sigma, it represents summation. Another mathematical operator we use for summation is the integration. It is part of calculus. In calculus, there are two sections. One is differentiation and integration. So mean absolute error, the formula, this formula is really important. It's a simple formula only. We are y dash represents the predicted value. See, you have the predicted value and the expected value. So two things are there. One is the machine learning model predicts the value, that is the predicted value, but it can be different from the expected value or actual value. So the predicted value minus actual value, we will take it as y dash. Y dash is this is the predicted, this y dash, it is known as the predicted value. It is the predicted value, and y is the expected. Y dash is the predicted value, and y is the expected value. So from this, what you can understand here is it is predicted and y is the